Hello students, welcome to the Fundamental Physics Lab. Today we're going to go over Optics-03, the prism. So first of all, we're going to go over quickly what is a prism. So you all must have seen this picture before. When you talk about a white light, it actually is composed with many different lambdas or wavelength inside of it. So the prism would actually refract the lower wavelength or violet much harder than the red wavelength, which is 650. So that would mean the index of refractions are different for different color of light. So that would mean red would have the least index of refraction because it's less refracted, and then violet would have the highest index of refraction because it's most refracted. So we're going to look at the angle of dispersion where D is the angle between the original ray versus the observed ray. So in the setup, you're going to have like a colorimeter that is actually collecting the light from the source, and then you would have this slit. So if you shut the slit down, then the light that comes in would end up being like a straight up ray that looks like this. So this is the colorimeter right here. According to this, then the light would come in and then hit the prism. So same thing here, it would hit the prism. First of all, it would actually reflect. So this reflection would have the same angle because the angle of incident is equal to angle of reflection. And then it would refract once and refract twice. And this would be the angle of deviation that you will be observing. So in this case, we'll use two kind of lamps. One is the sodium lamp that would actually have only just one wavelength, the yellow. And then you would have the cadmium tubes, which has 5 different wavelengths, one red, one green, 2 blue, and then 1 violet. So again, it would be deviated differently because the wavelength is different, right? So we're going to start with the sodium lamp, which has only just one wavelength, and that's going to be the color yellow. So on the first part, you're going to observe the edge directly by shining the light from the colorimeter straight onto the tip of the prism, and then at the angle of the reflecting edge, then the light would actually reflect just like this. So from the theory, if you move the telescope around, this telescope would see the light that looks like that. So this is the sodium lamp. So as you close it up, then the sodium lamp would get closer to the center, and then this light would actually give you the diffraction pattern, and then you would observe this light coming in here, and then you would observe another light coming on this angle. So the only two angles when light is shown directly on top of a prism is twice the angle that you would observe from the prism itself. So you want to start finding the two light right here, which would end up to be like 120 degrees apart, and then find the location M and location N right here, subtract from one another, and then you would actually be able to calculate the A, which is half the differences between the angle. And usually when you twist this, you would actually have like a different light coming in. So as you twist to find the optimum point, then you should be able to focus the crosshair on top of the light coming out of the slit. Then on the second part, by using the sodium lamp, you would actually end up twisting this angle. So you want to try to create the incident angle to be from 40 to 65, and then within the range of 40 to 65 degree, then you would observe a light that reflect here. So set your telescope up here to find R first, and then twist it to find another beam, which is D right here. So from here, you would actually call this deviated beam called Q, and P is the principal incident ray. So if rays come here, you set this to be 0, so or 360 degrees. So the difference between the Q ray and the P ray would give you the deviation angle. So D, it can be calculated by the positioning of Q and P. And then for each different angle, you can set it up. So for example, if I want to set this up to be 40 degrees, then this would be another 40 degrees. So some of this would be 80 degrees. Since this is 180, so this would read something like 100. Okay, so you can do the calculation because in the incident ray would always come at the 0 degree or 360, and then the reflection would be the same angle as the angle of incident. Okay, and then by observing the other angle, then you would be able to calculate D, and then you want to vary I from 40, 45 up to 65, and then plot D versus I. So D versus I, the angle of incident versus the angle of deviation versus angle of incident, and then you want to find the minimum angle of deviation right here. Okay, so this is part 2. Then part 3. You want to find the minimum deviation angle of the cadmium lamp, and the cadmium lamp would have 5 different angle, 5 different minimum angle, and 5 different wavelength, right? Because each wavelength would actually come in. Since you can see here that the angle of deviation would actually start reducing and then increasing again. So you want to find a sweet spot where as you increase the incident angle, the D or this light would actually come towards from left to right until it hits a sweet spot where that's the minimum, and then it goes back where they were. So it would look something like this. So for example, if the light comes in this way, as I twist it, it would actually bounce back. Okay, so as that bounces back, that would be your minimum deviation angle. So you want to keep this twisting this prism until you find the location of that angle. And once you find that location of the angle where the deviation is the minimum, then you can actually start calculating the index of refraction from this equation just by using A from the first part, which should be around 60 degree, and then the DM is going to be the minimum deviation based on different color. So you want to find the location of minimum deviation of red, green, blue, and then violet. Okay. All right, so that would be it. Enjoy the lab. Thank you.